Okay, so can you hear me? Yeah. Okay. So hello and thank you that you find time for my presentation. It's about ABRT, and it is a collection of software that is used for kind of catching bugs, but we don't call them bugs anymore. We refer to them as problems because it doesn't have to be really a bug, and the abbreviation means automatic bug reporting tool. And it's not about automatic anymore, it's not about bug anymore, and it's not pretty much about reporting either. So yeah, it's our name. Anyway, in this presentation I will be talking about what we call ABRT stack, and it means that it's a collection of different software that is either some libraries or some graphical user interface or some web services. I will start with the first one, which is called the same way as the whole project, and it pretty much does two things. And first is that it contains languages and runtime hooks, and these hooks are placed in correct places, and where there is some unexpected behavior, these hooks are woken up and they notify ABRT daemon that there is something happening. For example, we have a hook for Python 3, and when there is unhandled exception, this hook notifies the daemon that there something happened and send the exception to this daemon. This daemon takes this what was given to it and then tries to collect as many information about the system as possible, because we want to know how the system looked and behaved in the time of crash, so the maintainers can have more information. Information that are collected are the basic one, like the user who ran the command, or what binary it was, or what command line was used to execute this command, but also some more specific like C groups or mount info and so on. When it collects all this information, it stores it in what we call a dump dir. It's pretty much just a directory that contains a lot of text files, and each text file is one information about system. So there is a dump dir that has a specific name, and there are file names like user or package and so on. And the last thing it does when the problem is recognized is that it notifies the user. And if you use Fedora, you probably know the pop-up on top of the screen that says something like, oops, there was some problem, or something like that. And yeah, ABRT, the main component, also when it collects data, it does some more processing, and for example it can find the binary which crashed, but it also tries to check the RTM database if it came from some package. If so, then saves the package name and the version, and also depending packages on it and so on. The other component that helps pretty much with this last part, the processing one, is called Satyr, and it's a collection of some low-level algorithms, and mostly for processing and parsing stack traces and traces. And the point of this is that we have different looking stack we get from GDB and different one from Python, but we need from both pretty much the same information, like file names and lines which were executed in the crash. And also it can do some analysis like normalize and trim, but the interesting one in this part is the comparing, because ABRT tries actively to recognize if there some different problems can come from the same source. For example, there can be crash from some music player that has graphical user interface, and for example with for watching images in our computer, and they both can crash. But ABRT takes both of these crashes and compares them and finds out that part of the stack is really similar, and probably some library that both of the components uses was the cause of the crash and not really the program that really crashed that user sees. And also it does some reporting, but it's pretty much just generating files that are well specified and can be used for reporting, so contains always the same information. And yeah, we support kernel space and user space. User space means C and C++ languages, and also interpreted like Python, Java. I think we also have JavaScript and Ruby now, and Python 2, Python 3. And as everything in ABRT, this is also pluginable, so you can write your own plugin for your own language or runtime. Just place it on correct places, and it will start collecting and parsing your language. It's kind of easy to create these plugins, like the basic structure, but implementing them inside is not that simple, so if you have a lot of free time, please do it, but it takes some effort. And last library we use is called libreport, and it's for reporting, and it contains a lot of reporting tools, and the basic ones are files or emails, and it just takes the dump-dir, the files, and it brings it into some file in a nice way, or it creates some basic email and can send this email as well. The much more interesting ones is Bugzilla and MantisBT. MantisBT is pretty much the same as Bugzilla, but CentOS uses it. And it can really help users to create a proper reports, because usually when user tries to report something into Bugzilla and is not familiar what is needed, user will just write something like this program crashed for me and please fix it. But when is libreport or ABRT used, it automatically puts there the version of operating system, the package version, if user agrees that backtrace, and also those files I mentioned like multi-infos, and if the user was root, who executed it, and so on and so on. Another really interesting one is FAF, but I will talk about it a bit later because it's our next component in ABRT state. And also in libreport we have one more very interesting thing, and it's workflows. And workflows are some description of either rules that needs to be matched, and this so that workflow can be used, and also set of rules that are going to be executed when this workflow is selected. And it looks pretty much that there is one workflow, for example, for Fedora that is for Python, let's say, and it says something like check if it's really on Fedora. So it just go to dump-dir, check the operating system version, and if it's Fedora, it's fine. Then check if it's Python, it's also in the dump-dir, and when it holds, then start executing the rules in order. And usually first one is reported into FAF, and second one is check if there is similar Bugzilla already reported. If there is not, then start the process of reporting to Bugzilla, and so on and so on. And these workflows is just XML files, and you can write your own if you want to do something differently, or you want your users, for example, if you manage your machines in your company, write your own reporting processes, and it can be dynamically loaded into libreport, and it just works. Okay, so these were some libraries, but we also provide some graphic user interface, and this is our application that is not nice looking, but kind of works. And on this column we can see all the problems that happen. It is also split into my, and system my means that happen to my user, that the one who runs this application, and system are other users and root. And I can see that I have some crash here, it's in PyLint, and I can see some details about it. And it's all, again, the information from dump-dir. So there is reason, there can be some backtrace, there is a crash function, command line, which package it was, but also the interesting ones like C groups or open file descriptors are there, and environment, and everything like that. And also it provides the reporting. We can see that it's already, okay, we cannot see, we can see that it's already reported to ABRT server. That's the alias for FAF. And I just open it now, and we'll get back to it a bit later. But also, when I click report, it now checks similar Bugzillas, and it finds there is none, and now are starting the process of reporting to Bugzilla. And it first asked me to write how I can reproduce it, or what I've been doing when the crash happened. I just wrote it, so I can just forward, and now I will make it bigger. Yeah, and now is interesting part because it wants to attach some files to Bugzilla, but we don't want user to read some information, and therefore we are asking user to review this, but also helping him with matching some sensitive words because there is a lot of files, and it for me it just catches that I have something in an environment, but users need to be careful about this because I've seen some Bugzillas where users send vector traces that contain their password and username, and they didn't notice that. So yeah, and then it just next step, and I'm afraid I will create a Bugzilla and I don't want to do that. No, it's fine, I can do one more. And now I'm going to select which one I want to really include in the Bugzilla. And if I would now say that I agree with it, and this means I will create private, I don't want that, then I can just forward and it would create Bugzilla, or it asks me to log in if I don't log in, but I think I have it set. And I can do it, why not? And now I just created Bugzilla, checking for fabricates, creating new bug. Yeah. And I created just new bug in Bugzilla. And I can check it.
When it's done, it gives you a link to click, so you don't have to do this.
Oh, it gave me a click?
Yeah.
Okay. Yeah, okay. Good point. So yeah, and there is new Bugzilla when it loads. Come on. Yeah. And it's already set the basic information like version 29 or component package. All these things are done automatically. Also there is URL for the fab. I will talk a bit later about, and there are some attached files like vector trace, environment, and so on. Yeah. So that's it. And back to the presentation. Yeah. So that was GNOME ABRT, but we also try to integrate into other tools. And now a question, who knows what a cockpit is? Okay, so 4 or 5 people. Okay, so just in short, I will demonstrate it. So cockpit is something they call a remote session in web browser, and it's something that should help not really experienced administrator to do complicated stuff on their Linux machines. And you just log in the same as you would log in your machine in whatever else session. And you are in the overview. And you can see CPU load and traffic network and everything. I can restart or shut down my machine. I can change time or name of machine or whatever. But also, interesting and useful one is managing containers. You can pull images, you can run images, you can kill containers.
You can manage VMs from here as well, but you need a plugin for that.
Yeah, and yeah, it's pluginable, and pretty much every other team tries to do their own plugin, so it's in Cockpit, because that's what now runs. And you can manage network and storage and do complicated stuff from this simple web UI, but also if you like your terminal, you can use your terminal the normal way as you would on your machine. But ABRT was not created by plugin, but it was integrated directly into logs, because ABRT also writes into journal what it found out. So we can just integrate it into journal. And if I look at the presentation, the severity looks a bit different, and there is only problems, which would show only problems called by ABRT. But latest release, they kind of broke it, and now it's
Critical number.
yeah, there is bug because it should definitely not be only ABRT, but I reported them, but nobody fixed it. But they have different icons, and they have count, and you can click it, and you can see basic information that's from journal message, but also problem information, which again is from down here, like what component or which package and so on. And also, if there are files that are more complicated, like mount info, it's just here, or namespaces that represent it. So yeah, that's also how you can use ABRT. And also you can report, but only now into FAF, not into Bugzilla or other workflows. And this is working, I'm working on it just right now, so hopefully soon there you can report from Cockpit also into Bugzilla or other tools. Yeah. And now I'm getting to the last part that ABRT supports, and it's a web stack. And we have two web applications, and first is Retrace server, and it's really simple application. It does one thing, and that is it takes core dump and returns you backtrace or prepare your environment, and you can jump into GDB and work from with your core dump. And maybe some will think, why should I send my core dump over internet to some server if it may contain sensitive information? And you are right. We always ask the user if he is fine with it or wants to do it locally. If it wants to do it locally, we have tools that can do it locally. But if you decide to send it on server, it's just simple for you, or you don't have to download or debug infos and install it and build your system with this, and also consume your CPU. So always up to you.
Stands for?
Sorry?
What FAF stands for?
Yeah, I'm getting to that. And that's also another great name because it stands for Fedora Analysis Framework, and it's not about Fedora anymore. So it's just like old name that we kinda use it now like ABRT server, but it's still repositories and everything is called FAF, so it's just there. And it does one thing also, or maybe more things, and it takes view records, micro records, it's correctly pronounced, micro records, which are by design by design anonymous, and we collect them from all of users of Fedora who agree to send them, but usually they do, because they don't know they are agreeing with that. And you are asked when you install it, you have a pop-up and ask if you want to send it, but nobody knows what you are sending. And you send it to our servers and we collect them. I will demonstrate this, right? And at first I will show how a micro record looks like, so it's really anonymous, because you have only basic information about your machine, that is Fedora 29 and its workstation.
Could you make the text bigger?
Yeah, I can do that.
Oh, okay.
Okay, so only the basic information about system and also about the reporting tool, and there is basic information about the problem, that it was in which component, if the user were root or not root, and which signal it got, executable, and then there is just stack trace, which is quite long. And the stack trace, each frame contains only address, build ID, offset, function name, and file name. So all of this information are not private, and user shouldn't leak or cannot leak any data with that. And the last part it contains is list of packages that were affected by this crash with their versions. So we can know which version of libraries you had when it crashed. And all of that goes into FAF, which is this. And I will start with this. And if you just go to the URL is simple, it's the retrace.fedora project or /FAF, or you can go without the dash and you can click there. and it provides basic timelines, how many problems we receive every day, or you can change filter on different releases or in a daily basis or on long period, or different component. And this is some basic overview to see how broken your components are. And I can list this one and maybe not on CentOS because that's something different. Only Fedoras. And we can see that this is Fedora 29, the green one, and it from October 29, 30, when it was released, it just goes up, and this is Fedora 28, and it just goes down as, and in fact, I think now we still have more Fedora 28, but it's going to overpass.
How many reports are there? Because
that's 250, 200.
What's the scale?
Sorry?
What's the scale? Is daily?
It's 0, 50, 100. So
What's
around,
the time range?
date by date, October 27, 28. So every day around 200 or 100 reports from example Fedora 29 and growing. And this is just some overview, and it's not much use, it's only if you want to know how good we are or bad we are. But more interesting one is if you look into reports, and this is for example the report I reported, and I can see it happened already 3 times, and I can see related packages, and I can see also graphs how many, which day it happened, and it happened only last week, and I'm pretty sure all of 3 reports are mine.
Can you correlate somehow reports like that between releases?
Sorry?
Can you correlate reports like that between releases? So let's say that I would like to move to Rawhide, for example, and maybe I just want to take a look at the graph like that to see how many bugs are there, whether it's safe now or should I wait a bit?
Well, you can look into the basic overview and just select Rawhide and see how many bugs there are, or just filter for your component you are interested in. But it doesn't give you much information, because in Rawhide we get minimum of reports because not many people use it, and people who usually use it don't disable reporting it or so on. So if you look, for example, compare Fedora 28 with Rawhide, we get like 1 or 2 reports a day from Rawhide, but like 5,000 from Fedora 28. So.
What about other distributions like Ubuntu or any Debian or whatever?
It is also very easily pluginable, and you can write your own plugin for whatever release you want. Supporting Ubuntu or Debian wouldn't be easy on the fast side. I could do it probably in half day, and I would support Debian on it. The hard problem would be reporting from Debian this kind of information. Well, if you can just send me this looking or similar, because it's set in the plugin I would write for the fast server, but you need to generate this kind of information from your Ubuntu machine and send it just like a file and then interface. So it's not hard to do it on the server side, but it's harder to do it on the machine side. And I was reports. Yeah, there is a list of reports. So I can see some basic information about report, but it's still not really usable because we count how many times it happened, but it has to be the same stack trace. But usually the stack trace differ a bit because there are some different lines and so on. But we are doing one thing, and that we are trying to deduplicate or cluster together different reports that we think comes from the same problem. And for example, if I look here, and I think maybe this one would be interesting. So let's open it. Yeah. So
can you make the font bigger?
Yeah, I can do it. Yeah, okay. So I can see it happen on Fedora 26 and 27, but not 28. So probably in 28 it's already fixed because we haven't received any crash from there. And I can see it happen pretty much for a year. And affected components here are very interesting because we have here piling, we have here well, I don't ABRT, which is interesting, DNF, and a component, no ABRT, that don't have anything pretty much in common, but they are all our tools said that they are very similar together. So there probably is something they share together, and there is the cause of the problem. And when I look into related packages, it's by count, and it happened around 40,000 times, 44,000 times, and 44,000 times it happened in Python 3 or glibc. So probably one of these was broken. And I can see also, this, I see versions, and I can see that Python 3.6 is the same, always the same, and also glib 2.25 or 26. And I can go down, and I have here also backtrace, and I can see that it pretty much is in Python 3 library, or maybe, no, it's probably in Python 3 library because this is only for, it's only ABRT. So it happens probably in this function. So it seems that there was a problem with Python 3.6, and many components were affected by that. And that's where we are good at, because you get a report with connected this URL, and when you look at it, you can see that not only your component is being affected, but many other components, and that it's, for example, all of them have Python 3.6. So you know that it's not your problem, and you probably don't have to care that much about that, and it's not your problem, but your library's problem. And also this can be used by maintainers for prioritizing their work, because when you look into count and you can see that something happened, well, let's see, is it 10 million? I think it's 10 million times. That means that it's happening really a lot, and you probably should look into that. But if there is something happening, like, okay, 328 times, or there are a lot of that happen only once, and you get a Bugzilla because there is some really active user that wants to always open Bugzilla, but you see that only happened to him and only once, you probably don't have to investigate it immediately, because it's maybe only his machine that he broke something. We had some reports that someone reported our components are broken, but then we found out that the user was compiling his own libraries. I think it was SSL or something like that, and that it didn't work with our components well. So that's how can be used by maintainers, and can help them to prioritize and find out if it's really their problem, or if it's probably library, or how many times it happens, and so on. Okay, and last thing I will just kind of mention is that how we work with containers. And it's quite interesting topic now, because everyone wants to use containers, but catching problems from containers is not sometimes straightforward. And the first problem was if ABRT should run on host or in container, because when you want to have only containers on a machine, you don't want to install ABRT there. But it seems that it doesn't make sense to run ABRT in container, because it needs to be privileged and do a lot of stuff touching the host, and it just doesn't make sense to run it in container, but it can be done. We have proved that we can do it easily, but the container needs a lot of privileges. So ABRT should run on the host. And when we want to catch the crashes in C and C++, it's straightforward, because it goes through kernel, and kernel is shared for all containers, so we can do it easily. But the problem is with interpreted languages, because they don't jump out of the container. So we created some tool that is called container exception logger, and it's quite simple set-to-ID binary that can be contacted by hooks of the interpreted languages that are in container, and it can print this exception outside the container of their standard output, and we can read it from there by the daemons or some watchers. and then continue processing it. But there is still a problem that we are pretty much fighting. Still, that we cannot collect all the information we were able to do before, because we cannot sometimes get the same information from containers, such as package versions. Because not only that people often build containers differently than the packages in them, right? But also, when the container is dead, we cannot jump into that and connect to the ABRT database and so on. So that's kinda one problem we have, that we cannot provide that proper reports. So yeah, that's pretty much it from me, and there is some contact on us. We are open source community, so feel free to contribute. We are always happy for the contributors, and yeah, thank you. If you have questions.
Yeah, I have a quick question, because you said it helps package maintainers look at problems associated with the packages. I cannot find a way to show me problems with my packages in path.
Okay.
Can you show this?
What are your packages?
Sorry?
You just will through your package name there.
But I want for all my packages.
Yeah. Okay, that's a good point. You can log in by your first account here.
Yes, I did that.
And you have your name here.
Yes.
And
it shows me 0.
it shows 0 because.
And I know that there are reports for my packages.
Okay, and are those packages assigned to you?
I might be a co-maintainer for them.
We've been pulling this information from PackageDB, but it's not working anymore, so we are doing it from Azure now. And if you are assigned there, it should be there.
Yeah, I might not be the admin, but I have commit rights.
I think commit rights should be enough for you to see it. But okay, if it doesn't work, we can look at it after the. I will check if you have
it should work like this, okay?
It should work like that, definitely. That when you log in, you should automatically list only your problems.
Thank you.
Yeah.
I have a question. Because I can imagine that for C programs, when they seek faults, it's pretty easy to grab information from kernel because it receives it. But how exactly are you grabbing information about some Python script that crashed, and not the Python library, but just the application? Where do you get that information from, and how ABRT is doing that?
You have to have a hook for it, and you put it in some Python location that it expects it, and then when there is some exception unhandled by your running script, then it goes through Python, and it looks if there is something that wants to handle this exception. And if there is nothing, then we are like the default, and our handling tool is used for that. So then it's notified that there was this exception, and we are pretty much handling it, but we just rewrite it again, but also write it to different locations.
So it's like you're running modified Python to notify about crashes, or it's just building Python?
It enables you to write your own handling scripts, and we just did that. That if no one handles it before it would rise out of Python and it would crash, then this script is used that we place there, and it's not modified. You cannot do it by yourself right there in some specific format. It's somewhere documented how it should look like.
Thank you.
Yeah.
I have a very similar question. Is it possible now to distinguish between a crash in a Python script and in Python itself, in Python interpreter?
Python interpreter is written in C.
Yes.
So yeah, you have crash from C, and from Python you don't have really crashes. From Python you have unhandled exceptions. Yeah.
I have a little pessimistic question, because you're showing us that there is an error that has not been fixed for 2 years, and it has 10 million occurrences, and nobody fixes it. So why do you bother with this project?
Okay, notice the component, and they run it heavily on CentOS, and it's in function get, and I think it's when parsing arguments, and I think the crash is something that you put invalid arguments and it writes this exception when it's vital, and it writes this invalid exception when you put an invalid configuration. And they run it by machines. For example, maybe it's from Facebook because they run it heavily on CentOS, and they do a lot of deployments, so they can play 10 million in a few days. So I think it's kind of related to this, and nobody's fixing it. Well, that's another problem, but not only with this, but pretty much with everything in open source, that something crashes, you report Bugzilla, but then it's closed after the end of release that nobody look at it. But it's about maintainers, like, we cannot force them to fix that. It's not our job that I would look into this page and would write maintainers of that component, hey, that is something happening to you. You can click it, and if I log in, there is another feature I will show you. Yeah, it's only on CentOS. And if you have enough privileges, and hope I have mine, that I've never set them, yeah, you can associate bug. And you can put there Bugzilla or another tracker.
I can tell you who maintains that package because he's working with me. So.
Yeah, I thought so. And you can attach their Bugzilla, and it will be checking the Bugzilla for status, and it can then send the information that it was fixed, it was not fixed, and we also in fact do something like, if it starts appearing in some version or new release, then we can notify or write to Bugzilla or something that it doesn't happen in the new release, that it's in Koji. We have, but no record come from that we assume that it was fixed, but also you can create new Bugzilla for that, or maybe you should want this just for this one. You can just click it, and it probably won't work because it's for CentOS, but you can create your Bugzilla by one button, and hopefully maintainers will look at it then. Okay, thank you.